In this video, we'll be learning about the binomial setting and the binomial formula. When we talk about the binomial probability distribution, we are referring to the probability of a success or a failure in an experiment that is repeated multiple times. You can easily remember this by paying attention to the prefix bi, which literally means two. For example, in bicycles there are two wheels and in binoculars there are two lenses. However, in binomial probabilities, there are two outcomes, a success or a failure. Before we do some practice problems, we need to talk about the binomial setting. The binomial setting must satisfy four conditions. The first condition is that the number of trials n must be fixed. The second condition is that there are only two possible outcomes for each trial. You can either have a success or a failure. The third condition is that the probability p of success must be constant for every trial. And finally, the fourth condition is that each trial must be independent. This means that the outcome of one trial does not influence the outcome of another trial. An experiment that satisfies these four conditions is called a binomial experiment. The binomial setting will make more sense after we do an example, so let's jump into it. If you flip a regular coin 3 times, what is the probability of getting exactly one head, and is this a binomial experiment? Feel free to pause the video at this point so you can try this question for yourself. Since the question says that we are flipping the coin 3 times, I will have 3 blank spaces, one for each flip. The first blank space is for the first flip, the second is for the second flip, and the third is for the third flip. In order to solve this problem, we have to realize that there are only 3 possible ways for us to get exactly one head. The first way is to get heads on the first flip and then tails on the second and third flip. The second way is to get tails on the first flip, heads on the second flip, and then tails on the third flip. The third and final way is to get tails on the first and second flip and then getting heads on the third flip. So overall, we see that there are 3 different outcomes where we get exactly one head, and we see that they vary based on the order. Now all we have to do is calculate the probabilities of each outcome and add them together to get the answer. We know that the probability for getting heads is 0.5, and the probability of getting tails is also 0.5. To calculate the probability of the first outcome, we will multiply the probability of heads times the probability of tails times the probability of tails again. This is equal to 0.5 times 0.5 times 0.5, and this is equal to 0.125. When we calculate the probabilities for the second and third outcome, you'll find that they will also be equal to 0.125. Now all we have to do is add these probabilities together to get the answer, and when we do, we get the probability of getting exactly one head, which is equal to 0.375. To check if this is a binomial experiment, we have to see if it satisfies the 4 binomial conditions. The first condition is satisfied because we have a fixed number of trials. N is equal to 3 because the experiment has to be repeated 3 times. In other words, the coin has to be flipped 3 times. The second condition is also satisfied because we can define a success as getting heads, and we can define a failure as not getting heads. This is the same as saying getting tails is a failure. The third condition is also satisfied because the probability p of success remained constant for every trial. In other words, the probability of getting heads is 0.5, and it stayed that way every time the coin was flipped. And finally, the fourth condition is also satisfied because each trial is independent. Getting heads or tails for one trial doesn't change the probability of getting heads or tails for the other trials. Since all 4 conditions are satisfied, we know that this is a binomial experiment. Now let's do a harder problem. Suppose we have 10 marbles in a box. We have 3 pink marbles, 2 green marbles, and 5 blue marbles. If we pick out 5 marbles with replacement, what is the probability of drawing exactly 2 green marbles, and is this a binomial experiment? Feel free to pause the video at this point so you can try this question for yourself. Before we calculate any probabilities, let's see if we have a binomial setting. Is there a fixed number of trials? Yes. N is equal to 5 because we are picking out 5 marbles. Are the 2 possible outcomes a success and a failure? Yes. A success is getting a green marble and a failure is not getting a green marble. Is the probability of success constant for each trial? Yes. Because we are doing the experiment with replacement, every time we conduct a trial or randomly pick out one marble, we put it back into the box before drawing another marble. If we didn't do this, the trials would become dependent on one another instead of being independent. In this case, the probability P of success is equal to the probability of getting one green marble, which is equal to 2 over 10 or 0.2. Are trials independent of each other? For the reasons mentioned previously, the answer is yes. Since all four conditions are satisfied, we know that this is a binomial experiment. To solve this problem, we need to write out all the possible ways of drawing exactly two green marbles. For example, one way is drawing a green marble on the first and second try, and then not drawing a green marble on the third, fourth, and fifth try. Another way could be only drawing a green marble on the second and fifth try. Notice that I decided to write a dashed line for not getting a green marble. This is because I don't care if the marble was blue or pink. If I don't get a green marble, it's a failure. In a binomial setting, we only care if we got a failure or a success. Overall, we see that there are 10 different ways of drawing two green marbles. We can properly reframe this by saying that there are 10 different ways of getting 2 successes and 3 failures. Now let's calculate some probabilities. The probability of a success is equal to the probability of drawing a green marble. Since there are 10 marbles in the box and only 2 of them are green, the probability of drawing a green marble is equal to 2 over 10 or 0.2. Therefore, the probability of a success is equal to 0.2. The probability of a failure is equal to the probability of not drawing a green marble. There are 10 marbles in the box and 8 of them aren't green, so the probability of not drawing a green marble is just 8 over 10 or 0.8. Therefore, the probability of a failure is equal to 0.8. Let's calculate the probability of the first outcome. We have 2 successes followed by 3 failures. So we will have 0.2 times 0.2 times 0.8 times 0.8 times 0.8, which gives us an answer of 0.02048. If we do a similar calculation for the rest of the outcomes, you should also get an answer of 0.02048. Notice how each of these 10 outcomes has the same probability. The reason for this is because each outcome has 2 successes and 3 failures, so it makes sense that they all have the same probabilities. Now to calculate the probability of drawing exactly 2 green marbles, all we have to do is add up all these probabilities together, and when we do, we get an answer of 0.2048. However, there's another way we can calculate this answer, and that is by using the binomial formula. The binomial formula looks like this. It looks a little scary, but let's break it down. K is the number of successes, N is the number of trials, and little p is the probability of success. What we have here in brackets represents the combination formula. It is often seen in scientific calculators as NCR, which is the same thing as saying N choose R. So for the binomial formula, we say that the probability of K is equal to N choose K times the probability of success little p raised to the number of successes K times the probability of failure, which is 1 minus p, raised to the number of failures, which is equal to N minus K. By using this formula, we are essentially giving ourselves a nice shortcut for calculating things. However, it's important to remember that we can only use this formula if we have a binomial experiment. Let's go back to the problem so I can show you how to use this formula. If we pick out 5 marbles with replacement, what is the probability of drawing exactly 2 green marbles? In this problem, N is equal to 5 since there are 5 trials. In other words, we are randomly picking out 5 marbles. K is equal to 2 since we are only concerned about getting exactly 2 successes. This is the same as getting exactly 2 green marbles. Little p is equal to 0.2 as this is the probability of success that we calculated earlier. Now all we have to do is plug these values into the formula and we'll get an answer. So the probability of drawing exactly 2 green marbles, in other words, the probability of getting 2 successes, is equal to 5 choose 2 times 0.2 squared times 1 minus 0.2 raised to the power of 5 minus 2. After this calculation, we get an answer of 0.2048, which is the same answer that we calculated from before. If you found this video helpful, consider supporting us on Patreon to help us make more videos. You can also visit our website at simplelearningpro.com to get access to many study guides and practice questions. Thanks for watching.